class, there's a reaction. Every unit, I'm holding you responsible for one reaction. And it's usually something that we don't know the mechanism for, or we can't write a very reasonable mechanism. In class, we went over in great detail the Wolf Kishner reduction. And the Wolf Kishner reduction involves taking some kind of a carbonyl compound like this, treating it with hydrazine, base, and triethylene glycol. Okay, and we went over this mechanism for almost a whole day. You should have a beautiful mechanism in your notes. And if you do this, you will get this compound and nitrogen gas. And we worked really hard on that mechanism. Now, this is the Wolf Kishner. There's a companion reaction from a synthetic perspective called the Clemmenson reduction. Now, what would be a companion to this reaction from a synthetic standpoint? This reaction is basic. You can tell from the conditions. You have what is essentially a diamine, which is basic, and you have KOH, which is basic. And the way we wrote the mechanism was all basic. If you were a synthetic chemist, what reaction would you like to have in your toolbox? You'd like to have the Clemmenson reduction, because the Clemmenson reduction accomplishes the exact same goal but under acidic conditions. And think about that. You know, sometimes you have groups that are sensitive to acid, sometimes you have groups that are sensitive to base, and you want to have a reaction in your toolbox where you can reduce this group down under acidic conditions, because it's possible you might have another functional group in the molecule that's base sensitive. So how would this reaction work? Well, we're not going to write a mechanism. It's somewhat complicated, but what you want to add, it would involve adding HCl in the presence of zinc amalgam, which is just zinc and mercury. Okay. When you do this, you get a reduction of the carbon down to an alkane, just as we described in class, but it's done under acidic conditions. We could probably write some kind of mechanism for this. You can try if you want, but it involves, you know, using these metals to donate electrons into this system, so it's a little more complicated than this one is. Okay, now, as I told you, synthetically speaking, certain groups can't survive. Certain groups can't survive the presence of the Grignard reagent. And we talked in class a little bit about using protecting groups. So be aware that you could also use the same protecting group that you learned about in class, which is the acetal and ketal, with lithium aluminum hydride reductions. So supposing you have a compound, I'm not going to be able to continue. I'm just stopping it right there.